Today we are going to discuss AutoMapper. Let's get to know different ways you can configure AutoMapper for different scenarios. This video series is split into two parts, AutoMapper Basics and AutoMapper Advanced. This is part 2, the Advanced. We will learn the following topics in this video. If you didn't watch part 1, check it out first. So let's resume to part 2. We are moving to more advanced scenario handling. Let's talk about property casing. Here you can see all properties in my source class is in Pascal case, and I made the destination class properties lowercase like this. Alright, do you think AutoMapper can handle it? Well, yes it can. It tries to adjust to cases in almost all scenarios automatically. However, if you want to specify the source and destination casing, there is an explicit way like this where you can define AutoMapper's configuration like this. Let's talk about when to use replace member. Alright, so let's say in my source class there is a new property called zip code. Alright, in my source class there is a zip code, and in my destination class there is a postal code instead, a new property called postal code. Here a zip code and here a postal code. Let's initialize zip code, which is in my source class. Alright, employee A is my source class. Now it is understandable that AutoMapper cannot map this automatically. Why? Because the names are different. Alright. So the obvious answer is to add a for member to make it map successfully, like this. However, if you think that both zip code and postal code seem similar, both have the code in the name as common, right? So in these kind of scenarios, there's a different ways to do this. So let's remove the for member that we already just added. Instead, we'll add replace member in the global configuration over here. Since the name code is common both places, we just say replace zip with postal when you scan through the source class. That's it. Now just run the code and see the result. As expected, it got mapped. Next scenario is on how to handle prefixes and postfixes in your source class. This is our source class, alright? Let's say we have a prefix on all of its property members. Since this model is an employee, it could be EMP prefix. Let's change here since we modified the source class. Alright, now if we simply map, AutoMapper skips all the properties. This is because we've broken the convention of using same names. In general, approach to resolve this is by adding a for member for each property. Pretty inconvenient, right? Like this, we have to add for each property to match with the source class. However, AutoMapper has a built-in mechanism to recognize prefixes. For this, you need to add a recognize prefix in the global configuration. A good thing is that if you have multiple prefixes like this is also got recognized. Now let's map and see. As you can see, without adding the for member for each property, it recognized the prefix and mapped it. Same applies to postfixes. Let's move to more realistic use cases. Almost all the time we have a complex model. That means your class has a property which is of type another class. Let's see an example. Here, let's say we declare a new class called salary. Alright, this class holds two properties, base salary and tax benefits. Now our source class has a property of type salary. To make it more clear, let's name it salary A for employee A. Now the same will go for employee B, our destination class, with salary B. Since we added a new property, let's define it. Now do you think AutoMapper can map complex classes automatically? Well, no, not by default. Let's see the error. The error says error mapping types, under which you can see salary. So in order to map a complex model, we have to create a map of all classes involved in your model. In simple terms, any classes you use inside your model also need to be here. Now let's map and see the result. As you can see, the complex object is got also mapped. Well, we are moving into collection mappings. A collection is nothing but a set of items. A list, array, IEnumerable, etc. all are collections. So what happens if we make our data a collection? As you can see, I am making our source a list of employee A. Let's add two items to the list to make it feel like a list. Now we will pass the list of employee A to AutoMapper and expect the list of B as a return. So what do you think? Do you think we need to add a new map for this list? Like here, similar to other maps, do we need to add a map for this list? Like this? Good news is, no, we don't need. AutoMapper can automatically detect collections and handle it. As you see here, it successfully mapped without doing anything. We just need to ensure we added mappings for the individual classes used by that list. Let's dig into more use cases. Let's talk about null collections. Remember we talked about AutoMapper can handle collections automatically, but there is a small issue. Let's say we have a list of string in our source class. Let's name it friends. The same goes for destination class, a list with the name friends. Imagine if I set the source list to null, otherwise not initialized, both are same. Now what happens if I map this? We will expect since the source list is null, destination list is also null. But check here, this is not null, this is an empty list. However, my source is null, so what's going on here? This is because AutoMapper by default initializes all the list even if the source is null. To prevent it, simply enable allow null collections in the global settings. Now map and you will see null on both the sides. Let's get more advanced. Let's understand AutoMapper's flattening feature. So what is flattening? We will discuss with an example. Look at our source class. We have a salary which contains base salary, right? Let's say in destination class, I remove the salary B class and its property. Then made it as a string and named it like salary base salary. So this name complies with AutoMapper's convention of flattening. Look at the source class. Salary contains base salary and in destination the property is salary base salary. Let's run it. Here we have the complex model salary and AutoMapper mapped it by flattening it into this property. Let's discuss when to use type converters. Here I have a date of birth. It's of type datetime. Let's say in my destination I have a string, not a datetime. Do you think it will map? Well, it will map. But how? As you can see here, if it's an implicit conversion is available, it uses that. However, let's say our use case is custom and only need the time part. In this kind of scenario is dealt with a type converter. Create a class called datetime converter. And implement the iType converter from AutoMapper. Pass the source type and destination type. And implement the interface. Here you get the source as datetime and return the type as a string. You can do your logic here. In my case, I am only interested in the time part from this datetime. Once done, return it as a string. Now it's time to register this type converter. For that, go to the mapping profile. Create a map from datetime to string. Then register our converter. That's it. Now let's try to map it and see the result. Let's put a debugger in our type converter just to ensure AutoMapper uses it. Now this is the datetime and mapping started. We came here, executed our custom logic and we got the time only mapped. Now let's talk about value resolvers. Let's say in my source class I have this salary object, but in my destination class I have a new integer property called total. My intention is I want this base salary and total benefits added and summed into total during the mapping. To achieve these kind of scenarios, we can use a value resolver. Let's name it total value resolver since we are finding total. And implement iValue resolver. It has 3 parameters. Provide the source class, the destination class and the return type of the total, which is of course integer. And implement the interface. Here we can do our logic for summing up. Both source and destination instance is available. Just calculate and return. Now we have to register this value resolver. We do this by mapping total from the value resolver instead. So we say map from like this. That's it. Now if we run the code, we get the total value calculated. We can put a debugger to see the control flow. Our logic execute here. And here's the mapped outcome. Now let's talk about conditional mapping. See, here I have my country mapped, right? USA. Like, what if I map it only if it is USA? For these kind of scenarios, we can use conditional mappings, in which we add a condition saying that map only if the country is USA only. We can add a condition like this. And let's run it. Now it got mapped because it's USA. Now let's change the country to Brazil and run it again. And you see it's not mapped. Let's move to when to use preconditions, rather conditions. Let's say this total value resolver is very computationally intensive process. We need to run it only if the salary is available. So what's the solution? So let's add a precondition saying that run the resolver only if the salary is present in the source, because we are calculating the total salary. Let's put a debugger in the resolver class. We run it, salary is there, and debugger hit. Now let's comment the salary. Run it again. Now the debugger is not hitting. As you can see, condition and precondition works differently because precondition always run before the mapping starts. Next, we will discuss on null substitution in AutoMapper. Let's say I keep my first name null. When I map this, obviously since the source is null, destination is also null. But what if I need a default value if map data is null? This is accomplished by adding a null substitute to first name. We will say if it's null, keep this value. Let's add a substitute. Now let's map it and see. The source is null, but the destination got substituted. This not only works for string, but for any type. Consider our friends list. The list can also hold null substitute values. If the list is null, we have this as the default values. Let's run it like this. And you see the result. Now we move into events. AutoMapper has support to do custom operations before or after mapping. To do that, just add a before map with source and destination parameters. Inside this, we can do anything that happens before mapping. Let's override ID from 1 to 100. Here it is 1. It's overridden to 100. Let's run it. Let's map and see. ID is 100 in the result. But did you see that it also changes the source class? This is due to reference update. Now let's add an AfterMap. Add AfterMap after this, similar to how we add BeforeMap. And override anything after mapping. Here I am concatenating the source first name and last name for the destination first name. Let's map it. Here is my source first name and last name from the source. And you see the result. Here I got the destination. We had covered how to use AutoMapper in most common scenarios. Thank you for watching.